Hi folks, we're going to do a problem with centripetal acceleration. Here goes. There's a nifty kitchen gadget out there called a salad spinner. You put wet lettuce into a perforated basket that's mounted on a rotating shaft. When you push the handle, the basket spins. Inertia removes the water, leaving behind dry lettuce. If the radius of the basket is 12 centimeters and the cylinder rotates at 2 revolutions per second, I want to know what's the centripetal acceleration at the outer walls of the basket and how many g's of acceleration are on your lettuce leaves. Now I know my radius here is 12 centimeters. That's going to be my radius. And let's write down all of our data. We know the radius is 12 centimeters. I am looking for centripetal acceleration. That's what I'm after. And I am told 2 revolutions per second. Okay. Now, I didn't label this because let's spend a little moment trying to figure out what this is. Revolutions per second. Let the units tell you what we've got. Something per second. Is that going to be a frequency or is that a period? Something per second, that's a frequency. So that's my data. I'm looking for centripetal acceleration, and I have 2 equations, v squared over r, or centripetal acceleration is 4 pi squared r over t squared. If these are my 2 equations, both of them contain r, and neither one contains frequency. But I can convert frequency to period and period to frequency. So I think this is going to be a 2-step problem. Step 1 is going to be to find period. And period is equal to 1 divided by frequency, 1 divided by 2 revolutions per second. Now, if you remember, revolutions is just a descriptive word. It's not a real unit. So what is 1 divided by 2? Yeah, 1 divided by 2 is half. So 0.5. And then seconds are in the sub-basement. They're going to come up, and I'm going to end up with a period of half a second. Now that I have t and r, I can use this equation to find out centripetal acceleration. So centripetal acceleration is 4 pi squared r t squared. My radius is 12 centimeters, and you know we can't mix centimeters with everything else, so I'm going to have to convert, move my decimal 2 places. So I'm going to have 4 pi squared 0.12 meters. Period is 0.5, and they started out the problem with 3 sig figs. I better preserve those 3 sig figs, and when I do the math, I end up with a centripetal acceleration of 18.95 meters per second squared. If I preserve this down to 3 sig figs, that's 19 meters per second squared. Everything's going to round up a little bit. Now, part B says, what are the number of g's? If you remember, g's are the centripetal acceleration or the acceleration something's undergoing divided by the acceleration of gravity. So 19 meters per second squared divided by 9.8 meters per second squared. These are going to cancel. G's is a ratio, and I end up with 1.93 g's. It would be a heck of a cool roller coaster ride for your lettuce. All right, see you later.